Hello everyone, welcome to this video. In this video we shall be taking up question number 12. So question 12 here tell us that the ratio of the sum of m and n terms of an AP that is given to be m square ratio n square, right? We need to show that the ratio of mth term with the nth term is 2m minus 1 is 2 to n minus 1, right? So we are given this ratio, the sum of first m terms to the sum of first n terms is equal to m square upon n square, and we know this is the formula for sum. Sn is equal to n by 2 2a plus n minus 1 times d, where the small a is the first term and d is the common difference. So here we can apply this formula onto this given term, so that we would have m by 2 2a plus m minus 1 times d, right? And here n by 2 2a plus n minus 1 times d, and this is equal to m square upon n square, correct? So from here you see this 2 and this 2 cancels with each other. This m here cancels with 1 power here, this n here cancels with 1 power here. So we are left with 2a plus m minus 1 times d, this term, 2a plus n minus 1 times d, this term, and here on the right hand side we would have m divided by n. So let's mark this as equation number 1. So solving this thing, because we wanted the ratio of am upon an, so what we can do from here, we can just simplify the terms. So we can cross multiply here the term, so that we would have m times of 2a plus n minus 1 d is equal to n times of 2a plus m minus 1 of d, right? We can simplify the brackets here, so that we would have the terms like this written here. So you see this term is what? This is m n d positive, and here also we have m n d positive. So that means when you shift one term to the left hand side, this would become negative and both would become 0, right? They would cancel each other's effect. So we are left with 2a, right? 2am, and here we have 2an, so that it would be 2a m minus n. Similarly, we are left with minus md and minus nd, and they are on opposite sides, so it would be minus of m minus nd. You can check this thing that after simplifying and taking d common and moving the terms to left hand side, we would have this expression. So from here you can take m minus n common. Why I have taken this minus sign common? It is because I wanted to make these two terms as equal, m minus n. So it would now give us the factors m minus n and 2a minus d, correct? Now the product of two terms is equal to 0, so that means either of the two terms is 0. So that means either 2a minus d is 0 or m minus n is 0. If m minus n is 0, that would give us m is equal to n. However, m and n, they are both different terms, so therefore we will reject this case and we will move with this case where we have 2a is equal to 2a minus d is equal to 0. So from here we obtain 2a is equal to d. So we will use this thing in order to evaluate this ratio am upon an. So what would be am upon an? According to formula of the mth term, it would be a plus m minus 1 times of d, and according to the formula for nth term, it would be a plus n minus 1 times of d, right? This and this. So because we know the value of d from the above expression, it is 2a, we can substitute here and here the value 2a and 2a and simplify. So you see, you can take a common from both the terms here, in the numerator as well as in the denominator. So in the numerator we would have a as common, so we are left with 1 here, m minus 1 into 2 here, so it would be 2m minus 2, so 1 plus 2m minus 2. Similarly, in the denominator we are left with 1 here, we are left with n minus 1 into 2, so it would be 1 plus 2n minus 2. So we can further simplify the terms. It would be 2m, 1 minus 2 is minus 1, so 2m minus 1, and 2n, 1 minus 2 is again minus 1, so 2n minus 1. And actually this is what we wanted to prove here in this question. So I hope you understood the proof of this question well. Well, that is it for this video. Thank you for watching.